Cool. So we talked about microphones, and we talked about how carbon microphones were the first microphones that were invented, and they stuck around for a long period of time. So let's do that one today. We're going to do two types of microphones, carbon microphone, and then we'll do the dynamic microphone. Both of those are pretty basic and simple to do. So we'll start off with the microphone that started it all, and it was the carbon microphone introduced to us by good man Edison. So here's what you do. Again, you just need some household stuff. You can go around in the kitchen and grab some supplies, and that's pretty much all you need. Maybe the workshop, the junk drawer, if you got one of those, that's where I would grab all this stuff from. Here's what we're going to use. So we're going to use two of these lids from like a little Tupperware thing. Get the cheap ones that are the giveaway kind. So you make some cookies and then send it away and give it away. You don't want it back. It's okay because you paid like $3 or something for a set of these. That's cool. So and the reason is that the plastic on it is really flexible. So you want the more flexible kind. So these are super duper cheap. You can get them at the dollar store, a whole pack. And anyway, so that's what I went with. Let me explain the concept here, what we're going to do. We're going to use some aluminum foil. You use a little 9-volt battery as our power supply, a couple of pieces of wire. I'll talk about the carbon that you can get and some binder clips, and that's pretty much all you need. It doesn't take very much. Let's get to it. Concept, though. The idea is that we take two pieces of wire and we send a little bit of power from a battery, send a little electricity down. And what we're going to do, we're going to cover both of these wires. In fact, we're going to increase the surface area of these wires by using some aluminum foil. So we're going to stick them like that, stick it like that. And then we're going to pour some carbon granules on top of it. Carbon is a semiconductor. So a semiconductor is not a conductor. It's not an insulator. It's kind of in between. It's not a really good conductor, but it's also not a complete and total insulator. So what happens is that whenever we send a voltage through here, carbon granules are on top, and that makes the connection between the two. And it's kind of conductive, a little bit conductive. As we push on those carbon granules, the voltage between increases. And as we relax, as we reduce the pressure on those carbon granules, the voltage decreases. So there's less voltage that goes through. And what we're going to be doing is smushing them in with this other lid, and then we're going to talk into this lid. And as we talk, that voltage is going to vary in direct relationship to our sound waves. So right, so it's basically creating this voltage variance with our sound waves as we push and pull, push and pull, push and pull whenever we talk into it. So that's the concept for the carbon microphone. I'll show you real quick. Pretty much almost done already, in fact, with building this thing. But let's do it real quick. I'll show you how to do it. A couple of tips along the way. I'm going to take my wire. Again, I need to increase the surface area of this wire so we can pour those carbon granules across it. What I'll do is just poke it through right there, fold it on over, make sure it's nice and properly well in there. Maybe fold it like this. Fold it over a little bit. And that's looking pretty good. So there you have it. That's what I got. A little increasing the surface area with aluminium foil for our British folk out there. So there is that. That's what we're going to do right there. Let's do the other side as well. So we got two wires. We'll do one for that side. And like the commutative property in math, what we do to one side, we do to the other side. Is that right? I think that's right. I don't know. It could be wrong. You guys are saying I'm right? Good. High school works. Cool. All right, good. So there we go. So we're going to fold this over. Put that there, just like that there. Foldy, foldy, foldy there. And there it is. So another one. Ta-da! Now what I'm going to do, work with me, wire. Work. Basically, I'm just going to move it so you can see it. There you go. So now I'm just going to use some tape, a little Scotch tape right here, and I'm going to tape these in place. So I'm just going to hold them right there. I'm not going to put it on top of the aluminum foil because I want that to conduct as much as it can. So I'm going to push it back just so it holds it in place, holding the wire in place right there. And then how far do these need to be apart? I don't know. They just need to not touch. You don't want it very far apart. Yeah, kind of put them a little bit close-ish like that. Something like that looks pretty good. Let's go ahead and lock that one in place with some good old Scotch tape. Cool. Oh, now we're cooking. Look at that. All right, there you go. Ta-da. Ta-da. Super duper simple. 2 wires, aluminum foil. They're kind of taped and holding in place right there. Super duper simple. There you go. And then we'll break out the carbon. Carbon. There we go. Carbon backwards. This thing, I don't know what's up with my camera. Anyway, but it's backwards. So, carbon. Where do you get this from? Science store? No, you get this from Walmart. Go into the what is it? The pet area, the pet part of the store, and then the aquarium section. You'll find this. It's activated carbon. And basically, you use this as a filter for your aquariums and tanks and that kind of stuff. Carbon's got a whole bunch of really cool properties. But anyway, you can go grab this for super duper cheap. Whole thing like this, I think it was like $5 or something. Not much. You don't need a whole lot of this anyway. I think it works well with charcoal. So if you got charcoal briquettes or something, you can break them up and use those. But here we go. This is what I got. So you just pour a little bit on top. Make sure you cover both of those contacts. Make a little pile in between. You don't need a whole lot. That's not very much. But again, there you go. So now it's covered right there. A little pile of it over top. And now I'm going to take my second little dish top right there and squish it, make a carbon sandwich. And then I'll take my favorite tool of all time, big, massive binder clips. Oh, yeah. And those are just super cool. I love these big binder clips. Anyway, so you just want to put these binder clips, one on one side and the other on the other side. And there we go. Okay. There's one side just to hold it in place. And you could probably use something else. I like binder clips just because, you know, I'm an Office Depot geek. I love office supplies, I guess, and you can do some cool stuff with office supplies. Who knew? I entertain myself very easily. Doesn't take much to make me happy. Anyway, so there we go. So now we've got our little carbon sandwich going right here. We need to get that out of the way. What do we need to do? We need to get this this audio into our computer. And we also need to get our battery hooked up to it as well. So let's provide a little power supply. So I'll use my alligator clip. Hungry little alligator, bites right there. Boop. Let's do this. I've got a cool little XLR connector. And on the other side, I've got my alligator clips. And now I can take, what am I going to do? Yeah, here we go. So I'm going to take one side of my carbon mic and clamp it right there. So now power is going through there, coming out the other side, and going over here to my my lead on this side. And then the other one, I'll just plug up right over here to the battery. So now it completes the circuit. So your power is going out, coming through, going through my carbon microphone, going back out to the battery and into my XLR connector. So my XLR connector, I'm going to plug it up to my little Focusrite as a little preamp right here. Basically, this converts, it helps to go into the sound card. This is kind of a sound card for my computer so that I can record this thing. Because I want to test it out and see how it actually works. But basically, this is kind of like the XLR on the microphone, right? We talked about male connectors, audio is coming out. So you can plug this up to like a board or anywhere else, and it'll work as a microphone. Really? Yeah, let's check it out. So, boom, plug it up right there, plug it into my computer, and let's record something with it. Let's test it out. So that didn't take very long. What was it, like 10 minutes at the most? And I talked about a whole lot of stuff as well. It's like a 5-minute project right there if you talk a whole lot. So let's present now. I'll show you what this looks like in Adobe Audition. I'll pull this up. Here comes Adobe Audition. I'm presenting to everyone. Good on me. I am sharing my screen. All right, cool. So let's bring up Adobe Audition. I'll hit the record button down here. I'll say, okie dokie, please start recording. Whoa, that's looking loud. Let's pull this volume down a little bit right here. Very good. That's okay. Cool. And now I'm going to talk into the microphone that we made, and see how this thing works. Check testing 1, 2, 3, 4. Mic check. This is a carbon microphone. I'm talking into the carbon microphone that I made from found materials at the house. I dug in a trash can and made this carbon microphone. Hopefully it sounds better than garbage. Here we go. So let's stop that. I've been looking at waveforms for many years, and this is a weird looking waveform. So what I'm going to do, I'm going to go into my spectral frequency display and take a look at this in here. And what I'm seeing is that down here, I got bass frequencies that are really loud. The bright colors tell me that those frequencies are loud. And I'm looking over here. We got low frequencies, high frequencies. So we've got some high frequencies up here. That's not that bad. But down here, we got the reds and the yellows. That's telling me that those frequencies are pretty loud. So what I'll do, I'll highlight all that. I'll come back to effects. I'll go to my graphic equalizer. And I'll say, take out my bass frequencies. I just pull them all down. And those high frequencies as well, pull those down as well. I'm just going to keep these mid-range frequencies, which is generally what my voice is like. So say okay to that. Boom. And then there, that took out a whole lot of that ambient noise. I'm going to do it again, hit F3 on the computer, and there we go. So now that's what we've got left. It's taking out a lot of that noise up in the higher frequencies. Still got a little bit of rumble in the background on those bass frequencies, but let's look back over here at the waveform. Oh, that looks a lot more normal. That looks like some of your audio productions right there. It looks a whole lot better. Looks like my audio productions. Let's listen to this now. See how it actually sounds. I'm going to crank this up. Hopefully you can hear it through these through this microphone. I'll play it a little bit loud. Here you go.
Check testing 1, check test 2, 3, 4. Mic check. This is a carbon microphone. I'm talking into the carbon microphone that I made from found materials at the house. I dug in a trash can and made this carbon microphone. Hopefully it sounds better than garbage. Here we go.
Cool. That is so awesome. I think that's just phenomenal. That's super duper cool. Let me stop sharing. There we go. So there's that. There's my carbon microphone. And could y'all hear that? Give me a thumbs up if you could hear it. All right. That's cool. All right, good. Very good, very good. Oh, isn't that cool? You just made a microphone right out of stuff you found in the kitchen. That's unbelievable. Mom, I need to borrow your dishes real quick. I need to go record something for class. I need to borrow your... That's cool. All right, cool. So that is a carbon microphone. Again, why do they call it carbon microphone? Because we use carbon. It's an interesting thing. Again, this thing held together. It was in use for well over 100 years. Again, you found it mainly in telephones, but there were a whole lot of other applications as well out there. And they refined the technology over the years so that it sounded better and better and better. And yeah, it's just really robust. There's nothing to it. There's some carbon granules and ta-da, microphone. So it's very cost efficient. And it's robust. You can drop this thing all over you want. It's not going to break. Not very easy to break. So I think that's why it was in place for so long. Let's check out a dynamic microphone. Let's build one of those now. So let me disconnect this real quick. So we'll take that apart. We'll take this apart. One of the differences between the carbon microphone and the dynamic microphone, the big difference is that your power supply right there. That's kind of an important integral part of a carbon microphone, is that you have to have, oh, go over here, get out of the way, buddy. Thank you. You got to have that power supply. So that's cool. Let's move this out the way. We'll come back to that in a second. The dynamic microphone, though, creates its own power. So let's do this. Well, we don't need binder clips anymore. I'm going to get some other stuff. There, we need that. We'll need this. We need some rubber bands. We also need that. And then I need this. And then some tape. And I need wire. There you go. Dynamic microphone. Ta-da! You're looking at a dynamic microphone. It just hasn't been put together yet. But again, I got 2 rubber bands. I've got a little cap from like a hairspray bottle, or I don't know, Febreze bottle, all kinds of bottles. If you have a little spray bottle, they got the little cap on top, and so it prevents it from being sprayed. So you can find these all over the place. There's a powerful magnet. So this thing, I geek out on magnets. I love magnets, and this is a really powerful, strong one. This is an N50 magnet. You can find these on eBay. I think that's where I got these. They're probably easiest to find on eBay, but you can use pretty much any magnet. But I found that these work really, really well in this application, just because of the shape, the cylinder shape, and all that kind of stuff. It works well for a microphone. Little Dixie cup, so rinse after you brush your teeth, that kind of thing. There's that. We need kind of a long, thin wire. And then I put this together. This is really super simple. Go into the workshop and make this piece of 2x4, super easy to find. Some long screws, so some drywall screws, and then in there I've got a little steel screw that is screwed all the way into the board, so that I can put my magnet right there in the middle, and it holds on to it. This is going to serve as our shock mount, and also as our armature for our microphone. So we're going to use the rubber bands and basically create a shock mount for this thing, so the thing can float. And what are you talking about? A thing can float. So what we're going to do, we got a magnet right here, and we're going to make this wire. We're going to turn into a coil of wire that's going to go wrap around this thing, and the little Dixie cup's going to attach to it so we can talk into it. And as we talk into it, that coil of wire is going to move back and forth over that magnet. And as we saw earlier in the semester, when you have a coil of wire moving in over a magnet inside of I just lost all my words. Inside of a magnetic field, that's the word. Whenever you have a coil of wire moving in a magnetic field, it creates electricity. So it makes its own electricity just by moving back and forth. So that's really kind of super cool and an integral part of this dynamic microphone. So let's do that. We got all the parts and pieces here. Move it out the way so you can see it a little bit easier, and you can see what I'm doing. So again, if you want to make this at home, super duper simple. I'm just going to wrap this piece of wire around this little cap, so I get a little cylinder going here, and I'm going to put a little piece of tape on here just to hold it in place, because I don't have 4 hands. One of my shortcomings. There we go. So I'm going to just kind of stick that in right there so that I can get this thing started to coil around. So basically, this is going to be our voice coil, and just wrap it, and you can really easily wrap this thing. So there you see that. There you go. So you can see I got a little coil of wire going. Let's wrap this real quick. I think what you want to keep in mind with this is that you want thin wire, because the more turns that you have on this coil, the stronger the effect. So the more voltage is going to be created with the more turns that you have in your coil. So if you have a small or real thin wire, you can put a whole bunch of turns in your coil. There we go. So we get a little coil of wire, and there's my leads right there. So I got this in place. Let me put a little piece of tape on there just to hold this thing all together. So I'll just put a little tape, beep, just like that, and make sure it doesn't come unraveled. But there you go. That's my voice coil. Ta-da! That was simple. So my wire is coming out, coil all around that. Got it. Cool. So now this thing, when I move it back and forth right there, it's creating electricity right there. Oh no, I got shocked. No, I didn't get shocked because it's very low voltage. But nonetheless, if you put a meter up to this, it'll actually register electricity as you move the thing back and forth. Weird, but it works. It's really kind of cool. Okay, cool. Let's go ahead and attach this to it so we can talk into it, and this whole thing will move back and forth. So I had some double-sided tape earlier today that did not cooperate with me. While I'm doing this, keep in mind that tomorrow we're going to be doing our music presentations in class. So make sure you bring in some great tunes. I look forward to hearing what you bring into us tomorrow and doing your presentations on. All right, there we go. So now we've got these two. We're going to stick them together, beep, just like that. And now, ta-da, woo, yeah, magic. Okay, Scotch tape. Which reminds me of Christmas. Presents being wrapped. All right, so I'm going to put this in here. I'm going to get my rubber bands in there, right under the Dixie cup, and then I'm going to bring my little armature, whatever you want to call it, put that right there, and then we're going to stretch these rubber bands, just like that, and then just like this, so that this whole thing can float. Just a second. This is the tricky part. Not really tricky. Just got to finesse it a little bit. There. There. Get over there. There you go. Brilliant. Cool. All right, so there's that. There's that. This down. This down. This down. And there. Cool. All right, so there you go. A little bit lower. Don't want to go all the way down. You want this thing to kind of move back and forth pretty easily, right? So there you go. That's what we just did. So now we've got our voice coil. It's attached to our Dixie cup, so we can talk into this. Woo, woo, woo. You can move back and forth. Can you see that? So you can move back and forth pretty easily. It's suspended and held in place by our shock mount that we made with these rubber bands. And now we've got our two little leads. So as this thing moves back and forth, it's creating voltage right there. And we can plug that into our XLR and then into our system and see if we get any audio. So let's check that out real quick and see what happens. I made one a little bit earlier. That's pretty much the same thing, but I think I put a couple of extra turns in here, so it's a little bit more accurate. So let's hook that up real quick. See what we got. So back to my little preamp and my XLR cable, and then plug up this. That's the way. Put this over here, and see how this. If we get any audio out of it. The alligator clamps are biting today. There and there. Let me see. I want to take the weight off of that a little bit, so it's able to float pretty freely. There we go. That looks like it's moving. That's moving easy. Okay, cool. All right, now let's go ahead and present the screen again, and we'll take a look at Adobe Audition. Boom, boom, boom. All right, brilliant. So here we go.
Check testing 1, 2, 3, 4. Mic check.
Wow, that was a Carbon microphone. That's awesome. That audio came out better than I expected. So that's really cool. Let's do it again. We'll record real quick. Here we go. Hit the record button, and now we're recording. Here I am talking into my dynamic microphone. This microphone was made on my desk from scrap material, and here it is. Hopefully it is working. Let us take a look and see. So again, it recorded very, very low. So we'll have to crank that up. I'm going to go to my amplitude, hit the normalization, and boom! Oh my goodness, look at that. That doesn't look pretty. But again, we'll go back to the spectral frequency display, and it shows a different story. In fact, right here, I'm going to delete that and get rid of that. Basically, it was a little glitch in the system. It said, I can't record right there. But all of this down here looks like some useful information. So let me do my my equalizer again. So I'll go back to the graphic equalizer, take out the stuff aside from those mid-range tones of my voice. There we go. We'll hit F3 again, do it one more time, and that's looking pretty good. Let's go back to the waveform view. Oh, that looks a whole lot better. Go back to normalize it, and there we go. And let's listen back, see what we got. Here we go, coming down in 3, 2, 1.
Into my dynamic microphone. This microphone was made on my desk from scrap material. And here it is. Hopefully it is working. Let us take a look and see.
Cool. It worked. It worked again. That's awesome. Still blows me away that it actually works. So did you guys hear that? Thumbs up. Did you hear it? I like the carbon microphone better. It actually sounded better than that to me. But still, you know, let me throw together a microphone real quick. Whoa. And again, it supplies its own current. You create electricity out of this little contraption right here. And that kind of blows me away. So what can you do with that? Well, you can record stuff. I had several students in the past that were musicians, and they would build their own microphones, dynamic microphones, carbon microphones, whatever, capacitor microphones or condenser microphones, and they'd record themselves and use that in their own recordings. Some other people did some experimenting with it. There's the science projects that people would put together. And for a science project, it would be kind of interesting to see for a dynamic microphone, maybe you can do like, 5 or 6 different versions of it. What material works best as a diaphragm? Yeah, what's the size on it? Do you want lower mass? I would think that would be more accurate. Different materials you could use. Number of turns on the wire. How many turns of the wire do you have in your coil? The size of the wire, the gauge of the wire. You could use something that's like hair thin. Does that impact things? As you put more voltage through it, or it's creating more voltage, it's also creating heat. So there's a certain balance you got to strike. All kinds of little questions that come up. But that would be a really cool science experiment to kind of play around with and optimize this whole thing and put together a matrix of what parameters make for a really great dynamic microphone, or at least homemade microphone.